32. So it's negative the cube root of negative 64. What does how do you treat this negative sign right there?
I would put in parentheses.
Just yeah, I love that. Parentheses is a great idea. Just leave it alone. It's just along for the ride, right? So whatever you get with the rest, you just flip the sign. What does cube root mean? What does this 3 mean? What? Negative 64 to the 1/3 power. True. What does that mean, though? That means what to the third power equals negative 64. Exactly. What to the third power equals negative 64. You can answer that in your head if you want to. You could redo it. You could do this if you wanted to. Are you okay with that? Sure. Now, you could recognize what is negative 64. Yeah. So there's a, for example, 4. I could say, well, 4 is 2 squared, right?
Yes.
What's 9? 3 squared. What is 64?
4 squared.
It's negative 4 cubed. I'm telling you the long way. This is the long way to do this one, not the thinking in your head way. But are you with me so far? What's power of power? What do you do with powers of powers? Yeah, so right here, what do you do with these two right here? They become 1, so it's negative 4 to the first. What is that? So we just came up with the answer to the inside, right? But then what's floating out front? So you have negative 4, so it's equal to 4.
I have a question. Where did you get the 4?
I got the 4 because 64 is 4 cubed.
But okay, so I'm confused why you would put the.
I liked what Hannah suggested. Parentheses. I love that. That's great. Just don't tell them.
Hold it until the end.
Hold it till the end. Yeah, just ignore it. You know what you're going to do with it. Don't try to do everything at once. What does that 6 mean? That 6 through means we're looking for something that multiplied by itself 6 times equals 1 over 64, right? So I mean, you could write it as radical form. You could do it like this. Is equal to the 1/6. You could, if you want to rewrite it that way, that's fine. This is called radical form, and this is called exponential form. Radical and exponential form. So really what you're looking for is a number that multiplies by itself 6 times to get 64. What is that number?
2.
It's 2. So this is just 1/2. That's it.
Negative.
Nope, no negative.
Yes, with the negative.
Oh, with the negative. I'm sorry. Yes, you bring it to the end, right? So it turns into negative 1/2. Thank you very much, because we had it at the beginning. Absolutely. Yes?
What do you do with the 1/6? Wouldn't be 1 to the 1/6 over 2?
No. So yeah, so you could write it like this. So like 1 to the 1/6 over 64 to the 1/6, like that. That's equal to 1 over 2. Because the 6th root of 64 is 2. The 6th root of 64. So how do you write this? Well, it's because if you wanted to do this as an intermediary step, like the longer method, 1 to any power is what? 1, right? This is the 6th root of 64. What is the 6th root of 64? 1. Yeah. Do you want to see another cool trick?
Yes.
This will help you out. I think you'll like this. So you had this right here. We had 1 over 64 to the 1/6. Do you agree with that?
Yes.
Are you okay with that?
Yes.
I'm trying to think how I want to explain this to you. You know what? I'm gonna put a pin in this to come back to it once we've practiced this somewhere. I don't want to give you a tool before you master this stuff first, okay? These functions. So how would you go about graphing the square root of x? Do you understand what square root means? You can always make a table. This right here, you can always make a table. Do you see the numbers on the left here? Why were these numbers chosen right here for the x values? They're easily rooted, right? They're easily rooted. So once you got these numbers, these are a point. So that correlates to the point 9, 3. These two correlate to what point? 4, 2. So the points get plotted here, 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 and here. You connect them. Is that a line? It's a curve, right? What happens if I changed it? If there's the picture right there? What happened? It's a sideways parabola. Actually, it is a sideways parabola. Very good, yeah. If you looked at it sideways, it wouldn't be. That's correct. But you'll notice we're missing this part, right? There's no bottom part to that. If that was there, it wouldn't be a function, right? What happens if I did this? Same function, but then I added 2 to the outside. What happens to the graph of the function, do you think? It moves it.
It starts at 2.
It starts at 2, right? Exactly. And what's it going to do? It's going to do the same thing, but it's going to be
The y or subs 2.
same thing, but it's going to move up 2. Exactly. So this right here is y equals the square root of x plus 2. So what happens if I subtracted 2? It would go down 2, right? So this means it goes up 2. Y equals the square root of x minus 2 means down 2. Down 2. Let's do one that's a little bit trickier. Let's say I asked you for y equals the square root of x plus 2. So you see the difference? Where did I put the plus 2? In the inside, right? So this is inside now. Anybody want to guess? It moves. It doesn't change shape. It just moves. Anybody want to guess?
You would, in a table, you do like the x and plus 2.
Yeah, something 2. It goes 2 in what direction? Anybody want to guess?
To the left.
To the right or to the left? And now we're in that Cupid shuffle dance, right? Yeah. Who thinks it's to the right? Who thinks it's to the left? Couple? Let's take a look at this. Remember, the function's going to be this right here. What did I say you can always make to help you graph this? A table. So what would be some good x values to plug into this function?
0.
Really? You want to plug in 0?
Yeah.
2.
If you plug in 0, why would plugging in 0 be challenging? Do you know what the square root of 2 is? Exactly? No. So let's plug in. How about 2? What's another one? 7. I like 7, right?
47.
I like not 6. How about 14?
14.
Because when I plug in 2 into this, what do I get?
98.
2. Wait, 98? What? 2.
7.
What's 7 plus 2? What's 7 plus 2?
9.
Nah, 3 here. Oh, 4. How about if I plug in, can I plug in negative 2?
60.
It's going to be 0, right? So I don't know where they're getting 62 from. Okay.
You're trying to find squares.
I understand, but we're square rooting, kids. So that right there, are you okay with those points? When you plug in negative 2 into this, what do you get? 0. Negative 2 plus 2 is what? 0. What's the square root of 0? 0. So that's where this line comes from right there. So now, how many points do we now have? 4 of them. So now that you've completed a table, you can plot the points. So negative 2, 0 is right there. 2, 2. Negative 2, 0. 2, 2 is right here. Then you have 7, 3. So you have a graph that looks like this. So what happened? Did it go 2 left or 2 right? It went 2 to the left. So if you look at this pattern right here, what happens with this? What would this be? Y equals the square root of x minus 2. What happens? Right 2. Now, square root starts, can you plug in a number that's like negative over here? Over here. Why isn't the graph over here? Well, what's the function? Negative the square root of x. Can you square root a negative number? So what's the domain here? What's the domain? Greater than or equal to? All of these are what numbers? Positive numbers, right. Greater than or equal to 0. So let's change it just a little bit. What happens if I ask you about the cube root of x? The cube root of x. What's the domain here? Is there anything you can't? Oh, it's all real numbers, right? Can you take the cube root of a negative? Sure. What's the cube root of negative 8? 2. Right. So what does this look like? Well, we could make a table, x and y. We need to pick numbers that you can cube root. So how about negative 8, negative 1, 0, 1, 8? What's the cube root of negative 8? Negative 2, negative 1, 0, 1, and 2. We could do 27, right? When you graph these points, look what happens. You do have 0 here. You have 1, 1, and negative 1, 1. But then you have 8, 2, and negative 8, negative 2. What do you end up with for a shape? Little sideways F, like a stretched S. Now, what happens if I were to change it to y equals the cube root of x plus 2? What happens? No, it's not on the inside. It's on the outside of the cube root, right? So what's it going to do? Up 2, right. So it turns into this right there. If I subtract 2, what happens? It goes down 2. The basic idea is you need to now remember this is square root. And what is this? Cube root. This is actually any even root. and this right here is actually any odd root. Kind of cool? Maybe a little bit?
Yeah.
Okay. The last thing I want to end on with, because we only have a couple minutes left, is this idea right here. What happens, you know what this means, right? Oh, A. What does that mean? Can someone say what that says out loud?
It's an A or not?
It's not a to the nth power.
Well, that's A to the 1 over n.
It's the a to the 1 over n, which another way to, that's perfect. You could also say that's the nth root of a, right? Do you agree with that? What about this right here? Could I say this for me? What does that mean? The nth root of what?
A.
Of a to the m. Okay, it's the nth root. Okay. What power is nth root, Katie? You said it. What?
1 over n.
So that is a to the m to the 1 over n, right? What can you do with powers of powers? So this is equal to a to the m over n. So one thing you now have is the nth root of a to the m. That's the same thing as a to the m over n. So why is that important? It goes both directions. If I asked you for this, that's 8 to the 2/3. What does that mean? That means the square root of what? The cube root of 8 squared, right? The cube root of 8 squared? Does that kind of make sense?
Yeah.
Now, could you?
I don't know how you like would you
So then the
64 and then
cube root it. So what is that equal to?
wouldn't it be 4?
Yes, it is. That's correct. Absolutely. Very good. The idea is we were dealing with things that were like this before. 16 to the 1 over 4th, right? All I'm adding in 8.2 is that this number doesn't have to be 1, right? You're going to find it and then raise it to a power. The thing you need to remember is go small, then big. What I mean by that is this. Let's say I asked you for 27 to the 2/3. That means you can do it a couple ways here. You could do, if you wanted to, 27 squared to the 1/3. Why is that hard to do in your head? It's a big number, right? What did I tell you to do? Go small and then big. Or, how could you write it? 27 to the 1/3 squared. These are the same, right? Because what do you do with powers of powers? 2 times 5 is 5 times 2. It doesn't matter what order, right? What's the cube root of 27, Nate?
3,
What's 3 squared?
9.
Done. Go small and then big. Your homework tonight is listed in your syllabus. Have a good